Today we are making our way through 1C. This is specifically about logarithmic functions. So we're looking at the graphs of logarithms. Okay? So you remember last lesson in 1B, we were talking about skills involved in using logarithms, and now we're looking at the graphs of them specifically. So I would like to point out this page to you here, because this shows us something very fascinating about logarithmic graphs. So let's look at the first one. I've got y equals 2 to the x. That is an exponential graph, and you can see that it has an asymptote at the x-axis and then it goes up. Then I've got the graph of log in base 2 of x, and what you can see is that they are a reflection of one another about the line y equals x. Okay, they are what we call the inverse functions of one another. Let's move on to the next one. We've got e to the x and then the graph of ln of x. Okay, what is ln but the logarithm in base e? And you can see that they are the reflection of one another. Okay, if we had 10 to the x and log of x, we would see that they are the reflection of one another. So that's how we generate the graphs. Now when we started 1a, okay, 1a was about exponential functions, and we did some graphs of exponential functions. That's just a repeat of the information we already have, okay? So then we're looking at the stuff that is highlighted. The general function, the general form that applies to a logarithmic function in base A is, and then I've drawn it there, y equals a ln b of x takes c plus d, and with the properties that follow there. Okay, so we're going to be referring to that half of the page today. Let's turn the page. This table we'll come back to in a moment. That's going to tell us how we can get rid of logs. Okay. For now, let's leave that. Let's turn the page again. We're going to the first problem. 5 take 2.4 times e to the x plus 3. Now, this is an exponential function. So we did this question in 1a. For that reason, we will not do all of these parts. We are just going to do some of them. All right. I know it's an exponential function because remember, e is just a number, and so we have e to the power of x. All right. We know it's an exponential function because the variable is a power. Okay, it's an exponential function. And so part A, B, and C we sort of did when we were looking at 1a. So we're going to skip over those for now. And we're going to look specifically at part D. Find the x-intercept exactly, okay? Because there is a temptation to graph it and g-solve the x-intercept, all right? And that's generally fine, apart from when it says exactly. That means it wants us to find it in terms of e and ln and so forth. So the y-intercept occurs. Sorry, we're finding the x-intercept. The x-intercept occurs when y is 0. So that means we are going to solve this equation. 5 take 2e to the x plus 3, 2.4, equals 0. That is the equation that we are solving. We want to know what is the x value when y is 0. All right? So, to solve this equation, we need to isolate the variable term. We want to get e by itself. So we're going to break it down by first subtracting 5 from both sides. We'll have minus 2.4 e to the x plus 3 equals minus 5. We will divide both sides by 2.4. With minus 2.4. Okay, you can see the negative will cancel. And now we have isolated the e term. Okay, we've got e by itself. How do we get rid of e? We apply ln to both sides. Okay, now ln of e to the x plus 3 simplifies to x plus 3. And then it's just a matter of putting the 3 on the other side to get x by itself. Okay, so notice how it is exact. Okay? ln of 5 on 2.4 is going to be an irrational number with lots of decimal places. So we've got it including every decimal place when it's expressed in this form. If you put this in your calculator, you could round it to 3 significant figures, but the question asks us specifically to find it exactly. Now I've said I'm going to emphasise when we can represent things in different ways. So another way that this could be answered or represented is ln of 5 take ln of 2.4 take 3. Okay, the reason is if we have ln of A on B, we can write that as ln of A take ln of B. Now, when we get a question like that, solving it exactly, we're not fussy what it looks like, as long as you've just isolated x by itself. So either of these would be accepted. And I think the reason I stressed that to you guys was because in the textbook, they're very particular about the presentation that they use. So don't be alarmed if your answer's not the same, but do try and figure out how to get from yours to whatever they have. Okay, with E, right, E says find the value of x when y is 2.3. So that is a repeat of this process, isn't it? Except rather than we're finding x when y is 0, we're finding it when it's 2.3. So we will leave that one as an exercise for you guys to have a bit of a go at. Let's turn the page. All right, now we're on to the logarithmic functions. So this is what 1C is about. It is about logarithmic functions. So the first one, we've got y equals log in base 5 of x plus 3 take 2. All right, now the basic log function is like this. A ln b of x take c plus d. All right, that's the basic log function. That's a log function in base E. So looking at this one and this one, let's identify the values of A, B, C, and D and discuss the effects they have on the graph. A is 1. Okay, if there's nothing written there, it's 1. We've got one lot of log in base 5. B is also 1. Okay, because there's nothing written there, so the number that belongs there is 1. C is minus 3. Okay, we have to put minus 3 there. X take minus 3 gives you x plus 3. And D is minus 2. Okay, so C is minus 3. That's a horizontal translation, moves it 3 units left. Okay, what we've said, x plus 3 moves 3 units left, x take 3 would move 3 units right, and the minus 2 moves the whole function 2 units down. Okay, part B. Graph the function. So let's pull our calculators out because I need to show you how to graph log in base A. Alright? What you need to press is Option Calc. Alright? And you can see the log in base A button, log AB, and you can input it accordingly. Option Calc. So let's do a sketch of this one. For now, we will just sketch the graph, provide a rough sketch of it, and we can input the information a little bit later. I'll label the axes. I'll input the asymptote a bit later as well. This is log in base 5, x plus 3, Okay, so when you're graphing, right, and I've said you need to make sure the scale matches. Alright, what you can do is trace along it. Alright, and if you're tracing along it, that's going to give you a good idea of where it goes and in between what numbers it goes on your scale. Now you're going, hang on, your graph's a little bit different because it seems to just stop there. And that's a calculator error. It's a bit poor on behalf of Casio, really, but it does go down forever because there's an asymptote at -3. Okay, so we can see it on the graph because it just disappears. It doesn't exist for values less than -3, but we can also reflect on the information we're given for logarithms to prove it, which is what we're going to do now when we talk about the domain and range. So let's leave the graph like that for now, and let's go down to state the domain and range. Okay, firstly, the range. All right, I'm showing you where I'm getting this information from. Back here, we're talking about the general logarithm. Okay, the general logarithmic graph, that's on page 13. We've got the effects of A, B, C, and D. Range, right, very last dot point, range is Y-E-R, okay? For all logarithmic functions, the range is always Y-E-R, okay? Remember how it's an inverse of the exponential function, okay? For exponential functions, X-E-R. For logarithmic functions, Y-E-R, all right? But there is a vertical asymptote. Okay, and you can see C is the horizontal translation, hence X equals C is the vertical asymptote. What is C in this circumstance? -3. X equals -3 is our vertical asymptote. Alright, and so our domain then, we can see it exists for all values larger than -3. It does not exist at -3. It does not exist for values less than -3. It does exist for values larger than -3. Okay, that's A, B, C. Okay, find the Y-intercept exactly. Okay, find the Y-intercept. That's where it crosses the Y-axis. The Y-intercept occurs when X is 0. So let's take this equation and we're going to put X is 0 in there. We're going to have log in base 5 of 3, take 2. That's fine, we can represent it like that. Alright, that's what this value is. Log in base 5 of 3, take 2. Okay, next one. Find the value of X when Y is -2.5. So let's go here, A, B, C, D, E. Find the value of X when Y is minus, I'm looking at the right one. Find the value of X when Y is 2.3. So we have log in base 5 of X plus 3, take 2. We're saying find X when Y equals 2.3. Okay, that's what it's asked us to solve. Everyone on the same track? Yep. All right, solve for X. All right, this is our variable term. We want to get it by itself. So first, let's get rid of this -2. We're going to have log in base 5 of X plus 3 equals 4.3. Okay. How do we get rid of log in base 5? That's a little bit tricky. Let's remind you guys, if we have ln x equals 3, how do we get rid of ln? We apply e to both sides, okay? And that allows us to get rid of the ln. If we have log of x equals 4, okay, so we have a logarithm in base 10, how do we get rid of the logarithm? We apply 10 to the power of both sides. And that gives us x is 10 to the 4. All right, so we're starting to see a pattern. Here the base is e, so we apply e to both sides to get rid of it. Here the base is 10, we apply 10 to get rid of it. In fact, this is summarized on this table here. Okay, this is a table, Nick, on how to get rid of logarithms. So, given ln x equals 2, how do we solve for x? put e to the power of both sides. Okay? And so you can see whatever the base is, that's what you need to put to the power of both sides. What's the base we have here? 5. Let's put 5 to the power of both sides to get rid of the logarithms. Okay, so 5 and log in base 5 are going to cancel. We've got x plus 3 equals 5 to the power of 4.3. And then we just move the 3 over the other side. Wonderful. Okay, y equals 3, take ln x, take ln x, take 1 to the power of 5. Okay, step 1, identify the translations from the basic ln function. Here's the basic ln function. A ln b, x takes c plus d. Alright, it looks a little bit different because we've got this number 5 hanging up there. So let's move that first. We're going to have 3 take 5 ln of x take 1. Okay, now we're ready to assign the values of a, b, c, d. Now, a is not 3. Okay, it's not always the first number. A is always the coefficient. That means the number in front of the logarithm. What is the number in front of the logarithm? Minus 5. A is minus 5. B is 1. Okay, B is the number in front of this bracket. C is 1. Alright, that moves it 1 unit right. Which means this 3 hanging out here, D is plus 3, moves 3 units up. Okay, so let's just backtrack a little bit again. I want to point out these things here. A and B are going to affect the shape of the graph, okay? So we have A is -5, which means A is less than 0. So it's following this shape here. It's going to have a shape like this, okay? And we know because it's a logarithmic function, it has a vertical asymptote. It's going to have a shape like this. All right, so just pointing out that's what A does. Okay, part B, state the domain and range. Okay, for this function here, the domain and the range. Now, we can refer to our calculator, but what we should remember is that for all logarithmic functions, the range is YER, all logarithmic functions. Then we need to investigate the domain, okay? So let's flip back again to those dot points. I know, understand there's a bit of flipping back and forth. Second to last dot point, domain. X is greater than C or X is less than C. X is greater than C or X is less than C. What is C here? It's 1, okay? If this is our shape, we're going to say X is greater than C, X is greater than 1. Okay, that's how we're getting that number there. Feel free to use your calculator. Okay, I really encourage you to use your calculator, really. Alright, now I'm just going to emphasize this while I remember. ln of x, okay, and log of x, they only exist for positive values of x. Alright, so that means they don't exist at x is 0, and they don't exist for negative values. So that's the base function, but with horizontal translations that can change a bit. But remember, ln of 0, this is going to be something that pops up again and again and again. ln of 0 does not exist. There is no value that makes it true. Alright, do we have anything else to answer? Yes. Find the value of x when y is -5. Find the value of x when y is minus 5. So this is the equation we have here. 3 take ln x take 1 to the power of 5. Find the value of x when it equals minus 5. Okay, so what we want to do is get the ln term by itself. So in the next step, I'm going to get rid of the 3 and move the 5 down in front. Now minus 5 take 3 will be minus 8. Okay, so I've moved this number to be out front, and I've shoved that 3 over the other side. Okay, we'll divide both sides by minus 5. Okay, we want to get ex by itself, so how do we get rid of ln? E to the power of both sides. Excellent. Any questions about that? Wonderful. Let's get into 1C.
How do you know? When do you know for logarithmic functions? How do you know when x is greater than 0?
I don't get when x is going to ever be less.
What is it?
One more?
That's what we're saying.
Yeah.
No, wait, unless it's going.
For the logarithmic function, when is x going to be less than 6?
If b is negative.
Okay.
Yeah, because then
Oh, then it'll go that way. Yeah.
Okay.